Good afternoon, everybody. My name is Tomi Männikkö. I'm from Nokia Data Center Solutions R&D, and I will be presenting to you the Open Edge server and chassis. And this is what we are kind of proposing for the Edge server. Okay, so first we are.
Sorry, we're trying to get the color straight.
Okay.
There you go.
Yeah, so Nokia is a platinum member of OCP, and we are also a solution provider. So we are providing open rack based hardware already. So racks, servers, JBoards, and the likes. Okay, so here I have a picture just to quickly tell something about the background, why this kind of new hardware is needed. So in this picture you can see on the right side large-scale centralized data centers where typically there are hundreds of meters of rows of racks deployed. The kind of data centers that Facebook and Google and the likes run. And on the left side, we have the edge data centers, which is kind of the opposite of what comes to form factor and size and footprint. So at the edge, the processing needs to happen close to the users, and in case of telco applications, it typically means that they are located in base station sites, for example, or stadiums or places where the conditions are quite much different than in the centralized data centers. So we are seeing that there may be challenges with limited floor space, varying thermal conditions, and varying types of power feed that are available, to which we need to then adapt to. And the floor space limitation will be tackled by a smaller form factor. And varying thermal conditions will be tackled with extended temperature range. We do support both DC and AC power feed, and also three-phase, one-phase site power feed can be handled with different types of PDUs. And the power feed capacity may be limited to few kilowatts only. But there we are scalable from very small systems, so talking about a couple of servers, maybe a few hundred watts, all the way up to rack level solutions where a rack may consume already 10 to 20 kilowatts. So this system is highly scalable. And one of the important requirements for this system is the fact that we need to support different kinds of acceleration options. For example, for Cloud Run and multiple access edge computing. So there are needs for FPGA accelerators or GPUs and such. And we also want to utilize in our designs the well-known and design principles that have been found good and useful. So we are supporting centralized power feed, and it's all front access. So no need to go to the rear side of the unit. So maintenance is quite straightforward, and also maintenance is toolless. And vanity-free design is also important. So we are looking at more of the functionality and performance rather than good looks and secondary properties for for the hardware. Okay, so this is what the server is looking like. So it's a 3U chassis and 19-inch rack mountable. Dimensions are 130 millimeters by 440 millimeters by 430. So the width is of that of 19-inch equipment in general. But the depth is what makes the difference here. So with this 430 millimeter depth, we are able to fit into very shallow racks. And so we are able to fit into places where large racks, like even up to 1200 millimeter deep, are difficult to fit and even difficult to kind of take there through the doors. And so compactness is the key here. And in this chassis, we can place sleds in there. So we support 1U and 2U half-width sleds. There's redundant power feed, so 2 power supplies here. And then RMC, rack management controller. Basically here it's a chassis manager. So power feed capacity is up to 200 watts per chassis. And both AC and DC options are supported. So minus 48 volts and quite large range for the AC voltage. Sled power feed capacity is 400 watts for the 1U sled and 700 watts for the 2U sled. So this is basically the power feed capacity. We are not expecting that all applications, all server types will consume this much power, but it's just the design capacity for this chassis and the power supplies. So the block diagram looks like this. So quite simple, 2 PSUs connecting to the power distribution board here, and power is fed through these 2 boards all the way to the sleds in the backplane. And the RMC is managing the power supplies. So being able to read, for example, thermal temperatures, power feed, input current, output current, and so we are able to measure the power consumption of the entire chassis through this RMC. And the other important feature of the RMC is to provide hardware management connectivity all the way to the BMCs of the sleds. So one interface in the front connecting to all the sleds. So that kind of gives a convenient way to connect, not having to connect to individual servers always. And about cooling, the fan units are placed on the sleds, so we don't have any fans attached to this chassis itself. And we support both directions for the air, so front to rear, rear to front. And we are seeing use cases where this rear to front airflow direction is actually needed. Okay, so like I mentioned, the RMC is responsible for managing the power supply units and providing Ethernet connectivity to the sleds. So it's a 1 gigabit per second interface, 1000 base T through the front panel of the RMC. Yeah, so and the power feed is kind of centralized, so that these power supplies are feeding several servers, so they don't need to be individually fed. One power supply is able to feed the entire chassis to 2 kilowatts, and when both are operational, they operate in 1+1 manner, so sharing the load. Okay, so here you can see the structure of the chassis. So quite simple design, consisting of the steel enclosure, backplane assembly. So here you can see how they are placed inside the chassis. So backplane is where the sleds connect to get the power feed and the management Ethernet connectivity. And this power distribution board is where the PSUs and the RMC connect to. And then we have support brackets here. You can see maybe not that well in this picture, but we do support also 2U sleds. And in case it's all 1U, we have these support brackets here on the sides that then carry the weight of the 1U sleds. And when 2U sleds are used, these support brackets are taken out. And you can do that toolessly. And yeah, we don't have any data plane switching happening in this chassis because it's often more optimized to have it outside and be whatever is needed. The capacity can be what's needed, throughput and so on. Okay, this is the front of the chassis. Power supplies here on the lower left corner, RMC, and then the sleds. This slide shows how we can configure the chassis using different form factors of the sleds. You can mix and match 1U sleds to 2U sleds in the way shown here. The top row kind of you can replace 2 1U servers with 1 2U server. Okay, then to the server sled specifications. And this is for the 1U first. So 1U half width, and the width is 215 millimeters, height 41, and the depth 423. And power feed capacity and cooling capacity for this 1U sled is 400 watts. And we support, this is a single socket CPU in the first place. We support the Intel Xeon Scalable family. So we can support the entire range of CPU SKUs from the bottom of the SKU to the high end. And the maximum thermal design power is 205 watts. Then we support the Intel Quick Assist hardware acceleration in the PCH. We have currently two options available, the C621, the basic PCH, and then the 627 with the integrated Quick Assist functions. So this provides crypto acceleration and for example. So then that's a kind of a motherboard selection during the configuration phase when this is selected. And memory, so it's 6 channels, like you can see here, and we do support also 2 additional channels in certain locations where we can place the Intel Optane memories, the flash or type of memories that are persistent. So that will come with then with the Cascade Lake era of the CPUs. So currently it's Skylake. And the construction of the server is such that we have one single riser here, about here, and on the left side we have hot plug SSD slots, and on the right side we have PCIe extension slots, and both are connecting to the same riser. And the riser design, this blue block here, kind of defines in the server how the PCIe lanes are connected inside the server. So we can basically, with the redesign of the riser, we can redefine how the connectivity is made here. In the one use server, we support an OCP mezzanine in the bottom here, and one full height, half-length PCIe adding card slot. And the power feed capacity for that slot is 75 watts. So we can place a variety of acceleration cards in this slot when needed. And they are by 16 PCIe Gen 3. And storage, so on the left side we support 2 hot plug SSD slots, both SATA and NVMe are supported. So this is a 2.5-inch normal SSD with thickness of 7 or 9.5 millimeters. In addition, we support 2 internal M.2 SSDs, both of which can also be SATA or NVMe. Form factors are 2280 and 22110, so both lengths are supported. Okay, then next is the 2-use LED. Same motherboard in both. So the only thing is different is that the riser card is higher, and we are able to provide more I/O because there's more vertical space. So basically, pretty much the same stuff here. Power feed capacity for the 2-use sled is 700 watts, and we can support CPUs, queues with TDP up to 250 watts. And the same PCH options. And memory options are also the same. And with this riser of 2U of height, we can support 2 more slots of PCIe connectivity. And we also are able to support full-length PCIe cards in this 2U design because we are able to utilize the space on top of the DIMMs and the CPU heatsink here. So we are able to fit 2 full-length cards or perhaps one full-length dual-wide GPU card. And we are supporting power feed to such card up to 300 watts. So that can be, for example, a V100 GPU card, for example. And in the the half-length slot of 75 watts, we can support, for example, a P4 GPU card. And since we have a bit more height, also for the storage, we can support more hot plug disk slots. So the same two smaller form factors, so 7 or 9.5 millimeters high. And in addition, we support two higher slots with height for 15 millimeter discs. So this kind of gives us the option to use higher performing NVMe disks in the two top locations. And again, the connectivity is made through this riser. So in this, for the 2U server, we have two SKUs for the riser, providing slightly different connectivity. So one has more I/O, and the other one has a better connectivity to these two topmost SSD slots. So we can basically place by 4 NVMEs there with high performance. RMC is also plugged from the front. Okay, this is a bit repetition already. So management of the PSUs and access to the SLED BMCs. And yeah, so I did not mention this one yet. So to have this connectivity to several SLEDs, we have a switch on the RMC board. It's an unmanaged switch, so it's basically an extension to a wire, so it does only connectivity. And in the front panel of the RMC, we support debug console first, and then 2 SFP Plus cages for higher bandwidth management interface, and we have 2 of those so that we can chain these chassis together, even to kind of provide connectivity to even more SLEDs. So this can save a management switch in a rack level configuration, for example. Sorry?
Are you almost done?
Yeah, almost. Okay, then we do have a installation solution for 19-inch rack. So it's basically an aisle bracket integrated to a slide rail, provides adaptivity to front-rear post distance of 450 to 750 millimeters. So basically, from 600 millimeters deep racks to 1200 millimeter deep racks. And there's a grounding point in the front also. Am I out of time?
Yeah.
Okay. So.
And we want some questions.
Yeah. Okay. So just a quick summary of the environmental and regulatory compliance. So we do support temperatures up to plus 45 and short-term exceptional situations up to 55 and so on, and all the of course the normal EMC safety stuff, and also we are aiming at full NEPS compliance for this unit. Okay, so we are contributing this to the OCP Foundation. Our target is to have it an accepted product, so providing all the design files. Today we have stored the draft of this specification to the telco project wiki pages, so it's already there, and you can go take a look. So here's the link to that. I think that's it. And any quick questions? Okay, thank you.
Well, I actually do have one quick question. Meaning, I know this chassis was more focused on a server, right? Do you have any, I guess, view of how you can support other white boxes? Say, for example, because of these edge, meaning this is more targeting towards the compute, right? And I think there's very much a possibility that we could have other white boxes in the same location. And I think having a chassis, common chassis that could support other than just servers would also be beneficial.
Yes, so it is doable. Because the chassis only provides power feed and management connectivity, we can basically design any kind of sled. So it can be a gateway type of sled, or a J-board, or anything basically that fits into this form factor.
Okay, thank you.
Okay, thank you.